Okay, so in this video clip, we're going to take a look at using taking C++ code and wrapping it using Cython. And the idea here is if you have legacy code that you've built up maybe over time, or you spent, bit of effort in trying to already optimize the code, then converting it across to Python so that you can make use maybe of something as simple as a Python visualization tool like matplotlib. You may feel you're surrendering some of the value from your code. Now you can convert to NumPy or Numba or Cython, but we might prefer, in fact, keep the legacy code and use Cython as a bridge. So, in other words, have a Cython wrapper for C++. And the basic idea, simple enough, keep the optimized C++ code backend while accessing it through Python. Right now, our use case is the accounting for executive stock options, and we're taking Hull White 2004 lattice model, and we're applying boil-low optimization. Uh, we're also invoking dynamic memory management, removing sections of the tree that are not necessary for the estimation, and also dealing with the barrier. There's nonlinearity around the barrier, and also dealing with um, the early exercise, which has no effect here on the ultimately on the valuation of the option itself. So, in terms of once you've crossed the barrier, the option already exercises. So, perhaps long stories short, uh, we have some legacy plus C++ code. It's this one. Now we want to execute this code. So that's its main. We're going to create a main.cpp. The function here in C++ is dynamic truncate whole white boil low, right? So essentially, we want to take that C++ function and wrap it for Python. Uh, the core logic embedded in there is the whole white model. We then want to compile as a shared library. So we take that main.cpp as a shared library so that it can be linked to the Cython code. Then we need to set up the Cython wrapper. So we're not converting the C++ code to Cython. We're just using a Cython wrapper. And it's take note of the file name, uh, dynamic truncate whole white boil underscore whole white boil low is the Cython wrapper. Then set up the script file, specifies the Cython extension, links it to the shared library, and then the compilation and the testing. So before we execute here our main file, let's take a look in our content folder. And you'll notice that it's basically empty here except for the sample data. So when we write file main cpp, it should appear over here in our content folder. Okay, main.cpp. If you double click, you can see that file, write file is now appearing here. Then next step, following the chronology set out here, our next step involves compiling the C++ code into a shared library, right? So we execute that code and we're the library dynamic underscore whole white boil low dot so, right? Then we create the main, which is fairly typical with C++ code. And in a sense, we're declaring the variables, the stock price, the exercise, the time to maturity, the vest, which is the number of years that we have to wait before we can exercise the option, the interest, the volatility, the dividend, the exit rate, the amount of churn in the employment, and then, or the turnover employees, and then the barrier specification comes with the multiple. It's a double and m times or the multiple times the exercise is where the barrier lies, and then int the number of steps in a tree, and that's 1, 2, 3, 4, 5. So they're discrete steps. So we'll notice once we run this code, the main.h is appearing, the header file has come in. That's okay, that's there. Then we write the Cython file, dynamic truncate whole byte boil.px that acts as the wrapper for C++. So we execute that code, and again, it's appearing here in our file. Let's double click and take a look. Okay, so it's basically that file enters here. Okay, and then we write the file. So the Python setup script is used to build and compile the Cython extension that wraps around the C++ function. Okay, so let's execute this code again. And next cell, then Python setup build in place. Now we have that. If we double click, we can see the file as well. It's here, just basically taking what's here, and we can view it as a file, a .py file, and we execute. So the Python setup in place command, so it's used to compile and build the Cython extension specified in the setup file. Now, once we have done that, right, once we've created, um, went through these series of steps, that means then we can use from the that we can create it, that we can create once we come here, it's just a question of setting out our parameters, and now we want to have this Python function. So we call the wrap C++ function, and the Python function name is going to be dynamic truncate whole byte boil with the underscores. So let's execute that. That means then using the parameter values that we have here, we can output the value of the employee stock option. Now, again, we can test that against the actual values. If I go back to the table of content and come to the use case, the table of values that we have here, we can test the function. So this where we can now use this function in our Python environment to estimate the value of the option, but we're bridging using the Cython wrapper back to the C++ code. Let's just check that the code is working properly. So at the 5,000 steps, with the parameter values set out here, same as the values we have from CDiner, right? We obtained a value of 2785.35. So let's change for the next one. If we change, just keep everything else the same. Same parameters, just change the multiple to 2 and go to the 5,000 step. Let's make sure that the value is computing correctly, 34.99.60. 34.99.60. Change the exit rate. So go back, change the multiple to 1.5 and change the exit rate to 8%. So go from 4 to 8. Execute and see we get 2470, 2470.06, 2470.058 rounds up to 6. And if we lower to 500 steps, 500 steps in the tree, run again, the value we obtain 2470.002, 2470.0016 rounds to 2. So we can see here that the values are in agreement. Okay, let's go back then to to where we estimated the function using the taking the wrapped C++ function. We could include a timer here in the estimation. And one way of outputting uh, to investigate the speed of the function is time it, and you can see here it's taking 334 milliseconds. One additional thing we could do here just to see how that when we import in the Python helper function imported in, that's importing in the wrap C++ function, we could graph, so use the Python library matplotlib to graph out a series of different stock prices going from 50 to 150 for the same parameter values as before. I changed the multiple to 1.4 now and 9, basically 1.5. If we run that, you can see how we're now using the C++ function, but fusing it in with the code to run the graph using matplotlib. So we've combined, if you like, the speed of C++ with the flexibility of using a Python library like matplotlib. And so we get, in a sense, we can make use of, if we have a repository of old C++ code that's highly optimized, and we want to keep using that rather than convert into new code and new Python optimized code. The Cython library the Cython wrapper allows us to make that bridge. Okay, let's leave that there.